Standard error. As the sample size increases, the standard error of the mean increases. True or false? Well, the formula for the standard error of a sampling distribution is that sigma sub x bar, this is called the standard error, which is pretty much the standard deviation, but of a sampling distribution, all the possible sample means of a certain sample size. And so the formulation for that is sigma, the standard deviation of the original distribution of x values, divided by the square root of n. So whatever the sample size is that you're going to be taking to get each one of these x bars and make a whole distribution, like a whole bell curve of these x bars, this is going to be the new standard deviation of that sampling distribution. So this is how it is calculated. And notice that if your sample size is increasing, you're going to get larger and larger divisors, meaning that it'll make your overall number smaller and smaller because, you know, if you divide something like, let's say you divide 10 by 2, you get 5. But if you were to divide 10 by 5, you would get a smaller answer, right? Because you're dividing things into more pieces. So having the sample size in the denominator of the formula for the standard error means that as the sample size increases, actually your standard error would decrease. So this says as the sample size increases, the standard error of the mean increases. So this is false. And then part B says, suppose an unknown distribution has the following characteristics: a mean of 31, a standard deviation of 3.9. Determine the standard error of the mean if you draw random samples of 100. So if you take the standard deviation 3.9 there and divide it by the square root of the sample size, well, the square root of 100 is 10. So if I divide 3.9 by 10, that will move the decimal place back one place. So that would be my new standard deviation for the sampling distribution, the standard error.